Right, this is the example questions that I didn't solve in the class. So I'm recording it. So this is on hardness and how to remove, how to use um, types of chemicals that you normally use to treat hardness. I'll read the question. The chemical constituents of a groundwaters are carbon dioxide 22 milligram per liters, calcium 120 milligram per liter, magnesium, sodium's alkalinity. So this is a typo here, CO3 minus, um, and sulfate and chloride. So you have given a bunch of ions, including carbon dioxide. And pH of the solution is 7.2, which is within 5 to 8. That means you can assume all the alkalinity is as bicarbonate. You are in charge of operation of a facility to treat 10 million gallon day of groundwater. So this is the volume that you have to treat, the volume per day. So it will be 10 million gallon per day. Okay, so that's 10 divided 6 gallon per day. Why it is important? Because if you know how much volume of water you treat, you will be able to know how much of chemicals you need to treat or how much limes you need. So assume that extra lime is 30 milligram per liter as calcium carbonate needed to be added to the raised pH to precipitate magnesium hydroxide. Calculate the value. So it says extra lime means, whatever lime you calculate based on the equation, you got to add another 30 milligram per liter in addition to that, because that's something you needed. Okay, so let's see. So we have given all the concentrations. That's something I already wrote here. These are all given to you. And we know the molecular weights of all these carbon dioxide, calcium, everything is given. An equivalent per mole. You know this is carbon dioxide is the two equivalents per mole. Calcium 2 plus charge, so there are 2. Magnesium 2 plus charge, so this is 2. Sodium only 1 charge. Carbonate 1 charge. Sulfate 2 charge. Chloride 1 charge. So that's why. And then gram per equivalence. So that's equal to molecular weight divided by so gram per mole divided by equivalent per mole. So that will give you gram per equivalence. So molecular weight by equivalent per mole. Okay, so that will be 44 divided 2, so that will be 22. If you do the same thing, calculate, this will be this number. Just going to calculate 96 divided by 2, 48, 35.5. Now you want to calculate what this concentration is as calcium carbonate. Again, the way to do it is you put 22 times this number. Okay, 50 divided by um, 50 divided by this one. Okay, 22. So that's here. So this one will be 120. That's the concentrations, and the equivalent weight of calcium carbonate, which is 50 divided by equivalent weight of calcium. That's 20 over here. Okay. So if you do this one, it's 500, 361 times 50 by 12.515. So that will be 250, 46 times 50 by 23 would be 100, and 427 times 50 by 61, the 61 is here, that would be 350. So this is basically you are doing milligram per liter, which is here. I'm going to write the column number so that you can say what those are. So this is 1 times 50 gram divided by number 4. Okay, that's what we are doing. And here we are doing 2 divided by 3 to get 4. Okay, so the last one, 192 times 50 divided by 48, that will be 200. 71 times 50 divided by 35.5, that will be 100. Okay, so you got that numbers. Okay, So now you know every concentration as a function of calcium carbonate. Then you can add and subtract together from each other. So now you have to calculate different points. So total hardness. So let's see total hardness, what that would be. So again, that's calcium from magnesiums. If you know what that means, calcium is 300, magnesium is 250. So that's 300 plus 250. So that will be 550 milligram per liter as CaCO3. So now, so let's plot it. That's much easier to do. So we know that we need something around, let's say, all the positive charges. If we sum together, that will be 300 plus 250 plus 100. So that will be 650. So we need at least 700 around the length. So let's do this one. Let's say this is 0 and this is 100, 200, 300, 400, 500, 600, 700. Okay, so I'm just going to write 100, 200, 400. Oh no, that's 100, 200, 300, then 500, then 700. Okay. Now let's calculate calcium. Calcium is 300. So I'm just going to make calcium, which is 300. So let's me make it pink. So 300, that's calcium. Okay, that's up to here is calcium. Then 250 is magnesium. So 300 plus 250, that would be 550. So that's 500, this is 600. So 550 will be here, 550 scale. So I'm going to plot magnesium this much. Okay, so that's magnesium. And then we have also sodium is around 100. So I'm going to add another 100 to that. So that would be 550. So that will be 650. So that will be sodium. So if I do this one, let's say this is sodium. So sodium would be, let's say, yellow. So that's sodium. Okay, let's do the same thing. This is again 0. Let's make the negative one. Negative one is basically SCO3, sulfate, and chloride. So let's start with carbonate. So carbonate is 350, then 200 is sulfate, and 100 is chloride. So 350 first. So I'm going to draw 350, so that will be here. Okay, that's 350. Then 350 plus another 200, that will be 550. So that's already here. So that's so that should be sulfate. So this is SCO3. Then here to here it will be sulfate. And then you have chloride. Chloride is 700. So that's another 100. So that should be up to here, 650. So I'm going to draw that one. So let's see. So I'm going to draw that SCO3. And then I'm going to draw SO4. That's here. Then we have chloride. Chloride, maybe let's see. Well, make it chloride a little bit reddish. Okay. Okay, so that's chloride. So that add up together, same thing. So now it's all you have to do is plot the total total uh, total carbonate. Okay, total hardness. So total hardness is a calcium per magnesium. So that will be all the way here. Okay, calcium per magnesium total hardness. And then carbonate hardness is only small portion of it. So that won't be carbonate hardness. That means the rest of them would be non-carbonate hardness. Okay. Now you have to think of different species. So that means if you see the intersection up to here is all calcium is CaHCO3 because all calciums are there. So now you have this much amount remaining. That's magnesium, but we have carbonate here. So this amount would be magnesium SCO3. Okay. And then the rest of this amount is magnesium sulfate. And then you have sodium chloride this section. So you don't need that one for your calculation. So this would be, if you see what is that amount, this would be CaCO3. So what you got here, CaCO3 amount is up to 300 milligram per liter as calcium carbonate. If you think of how much magnesium SCO3 is this range, so that will be 300 and this is 350, so that will be only 50. And then if you think of what is magnesium sulfate, that's the non-carbonate hardness, rest of them. So this is 350, this is 550 minus 350 is going to be 200. Okay. Why this is important? Because you need to know all the species for you to calculate the all the other factors. So now let's see. We want to calculate this value, total lime concentrations. So what's the carbon dioxide concentration? Because lime is required to consume all that. So carbon dioxide, let's look from our solution here. Carbon dioxide is 50. Again, you have to add the same unit. So 50. CaCO3, we just calculated 300 plus 2 times magnesium, we calculated here 50 plus magnesium, which is the non-carbonate hardness. So only thing remaining is magnesium. So that's why we have remaining is whatever magnesium sulfate is. So that's 200. So that would be, if you calculate all that value, so that would be 650 milligram per liter as CaCO3. So the estimate of lime concentration, that will be 650 milligram per liter as calcium carbonate. Convert it to milligram per liter as lime. So that means I'm asking how much actually is as lime, because I am interested in lime. So if you see lime is CaOH, which is CaO, what's the amount would be if you have 650? So, well, this is 650 milligram of calcium carbonate, okay? And all you have to do is divide the equivalent weight of calcium carbonate as well as calcium the lime. So if you see equivalent weight of calcium carbonate, so that will be equivalent weight of calcium carbonate and equivalent weight of lime. Okay, so if you do that one, this will be 650. You know this one is 50. Okay, and this one calcium hydroxide. So calcium is, let's say, what's the molecular weight of calcium is 40. So 40 plus, so CaO means 40 plus oxygen is 16, so that will be 40 plus 1, so 56 gram per mole. But that's molecular weight. So if you think of what is the equivalent of calcium oxide, so calcium oxide, again, it has 2 plus because calcium goes to H2. If you think of this one, it says actually this is CaOH2. So it's actually 2 plus. So equivalent weight of calcium oxide is 56 divided by 2. So that will be 56 divided by 2. So if we put that value, it will be 364 milligram per liter. So that's the amount of the concentration of lime required per liter. Okay, that's the exact amount of lime concentrations. Now I ask you total lime. So total lime is basically concentration times volume. So volume is again 10 times 10 to the 6 gallon per day, right? That's what the volume you have to treat. Then you have to change to liter. So that's 3.785 liter is 1 gallon. Then that become liters. That's the volume. So this entire thing is volume term. And then you have to make the concentration term. So that will be 364 milligram of lime, okay, per liter. That's the concentrations, but you ask in terms of kilograms, so that means you have to change kilogram to milligram. So you know 10 to the 6 mil milligram is same as 1 kilogram. So this value you should be able to get 14413 kilogram per day. So that much lime you needed. The next question, or the next, is calculate the amount of soda ash needed. Again, soda ash formula is calcium, magnesium that's coming from non-carbonate hardness. If you think of what's a non-carbonate hardness, that's basically here magnesium. There is no calcium non-carbonate hardness, so this is the only thing remaining. So if you know this one, so that in this problem, this will be actually the amount of magnesium, okay? Because this is 0. There is no non-carbonate species containing calcium, okay? Because we have just magnesium sulfate. So estimate the lime concentration. So if you think of what is the lime concentration would be, the magnesium amount is how much? So that would be, okay, soda is needed. So let's see the equations. I just want to make sure that we correct. So sodium carbonate is needed for calcium that is added before, which become replace the magnesium. So NaCO3. So that's the amount we need. So let's see, that's the two equation coming from, one from calcium that is coming from before, as well as the magnesium. So this is all the equations. Okay, this calcium, this magnesium. So these are non-carbonate. So you have only magnesium. So we'll have to put the magnesium then here. So that would be this magnesium require calcium, then this calcium require to go to calcium carbonate. So okay, so one thing I forgot to say. So you have calcium here too. So that calcium that is there will require calcium carbonate. Okay, so that's magnesium plus calcium. So calcium is 0, so I'm going to put that value here. So what is the estimate lime concentration of magnesium carbonate? So magnesium is how much? Is 200. So that's the 200. That's the non-carbonate species, okay? And then the amount of Na, so you want to calculate as Na2CO3, not as CaCO3. Again, you do the same thing. You have multiply 200 milligram CaCO3, then molecular weight of, or the equivalent weight of calcium carbonate is 50, and equivalent of sodium carbonate is actually 106. That's the molecular weight divided by 2, because the 2 here. So the molecular weight of Na2CO3 is 106. Okay, so that would lead to 212 milligram per liter. So the total lime, again, same thing, 10 to the 6 gallon per day, then 6 liter per gallon. Then this is 200 milligram per liters, and then you have to change to kilogram. That'll be 8024 kilogram per day. Again, this is the volume, this is the concentrations. All right, so that's all. This is how you can solve it.